Graphs. Graphs plays an important role in physics, business, finance. We have seen many such graphs in business channels, right? Even in cricket, sports, they depend on graph. And you have read about different types of graphs. Hello students and welcome to 11th Standard Physics, first PUC Physics. This is a graph of, let me not say this is a graph of, this is a graph. This is how company A is performing. This is how company B is performing. If you have money with you and you want to invest, in which company you would like to invest, in which company you would like to put your money so that it can grow? Can you guess? So most of the cases students will choose A. But actually you should not choose between A and B because nothing is mentioned along y-axis and x-axis. If your answer is A, if your choice is A, then observe, if this graph is with respect to loss and year, you are in trouble, right? Because A, the loss is increasing with time, with year, whereas in B, loss is decreasing. Even answer B is also a wrong option because still B is under loss. Students, what you thought in the initial stage? You thought it should be the performance means profit of the company with respect to time. But actually, we have to decide based on y-axis and x-axis. Now look at the second graph. This is profit and time. Time in years. 2010, 2012, 2014. Okay. And this is how the company is doing. This is A, this is B. Certainly growth of A is better than growth of B because it is a graph of profit versus time. Since it is 2020, nothing is mentioned. It is clear up to say 2014 or 16 or 18, not beyond that. So all this information can be obtained from the graph. That is why it is appropriate to show the data through graphs. Nobody wants to go through all the statements. Instead of that, people prefer to analyze based on graph. If this is a graph of runs over in a cricket match, and this is how team A is performing, and this is how team B has performed. If it is 2020 match, this is 20th over because over 20, and this is somewhere around 150. Okay, this is B. See, many statements can be analyzed, seen in this graph, isn't it? Can you guess which team has batted first, opted for batting? It should be A, right? Because A has scored 150 in 20 overs and B failed to reach 150 but they just scored 100. Who won the match? It is supposed to be A. In cricket match, you might have observed such dots, and these dots represent wickets taken. Wickets taken in this over, in this over, in this over. If there are 10 wickets here, 10 dots, then nothing but they have lost all 10 wickets or 9 wickets, whatever it is. I'm not sure about the number. So this is how one can analyze. In physics also, we understand through graphs. They are important. Position time graph. Position or displacement. Okay. Displacement. You can see horizontal line parallel to time axis, parallel to x-axis. At every instant, this height remains same. This height remains same means position is fixed. So the object is not moving. So you are asked to find nature of motion using this graph. Then you have to write full. Okay, like this. Position time graph or curve represents a body at rest. Position time curve represents a body at rest. And here you can see increase in position with respect to time. So the object must be moving away from the point of observation. Origin means point of observation. Okay. So from the observation point, object is moving uniformly means these things will represent uniform velocity. Position time graph represents uniform velocity. Observe this. Position, nothing but displacement is decreasing. If you see, height is decreasing with respect to time. Means this object must be approaching the observer. If a vehicle is moving away from us, then its position increases, displacement increases. If vehicle is moving towards us, then position decreases, displacement decreases. So this also represents velocity, but negative velocity. This represents positive velocity. So I can write plus v. Here negative velocity. Negative velocity. Here position is changing to and fro. Position is changing to and fro means it could be some sort of oscillatory motion, and this is possible. So it is variable velocity because sometimes velocity is up positive, sometimes velocity is down negative, and you can see curved portion here. Means curved portion means velocity changes with respect to time. So it is appropriate to mention non-uniform motion. Position time. You can see wave pattern like this, and this is not possible in position time graph because if you consider this instant, it is at 4th second. Okay, at 4th second object can have different positions, isn't it? If I draw vertical line, then this vertical line cuts at many places, cuts the curve at many places, means position at 4th second, object is at a distance of 2 meter, object is at a distance of 4 meter, object is at a distance of 6 meter. Something like saying at 4th second a vehicle is at a distance of 2 kilometer, 4 kilometer, 6 kilometer. How is that possible? Body cannot occupy two places at the same time, isn't it? In that sense, this is not possible. Even this is not possible. You can also argue that the curve is going back. If you consider from this point, the curve is going front with respect to time. As time elapses, fine, motion. But here it is going back in time. In this mechanics is not possible. In this world it is not possible right now. We have heard of time travel, right? But let us not go to that. So these curves are not possible. You have to mention position time curve is not possible because body cannot travel back in time. Observe this. Straight line represents uniform velocity. Let me draw. This represents uniform velocity. But here the position is increasing rapidly. Rapid increase in position, rapid increase in displacement means this should be acceleration. Yes. Curved. This red curve represents acceleration. This green curve represents uniform velocity. This also represents acceleration. You can say retardation because displacement is decreasing, height is decreasing. After that it becomes horizontal, means a vehicle after applying brakes has stopped. So this represents retardation. This represents retardation. You can observe horizontal portion of the curve. You have to write like this. Position time graph represents for both. This is the statement. If there is a graph like this, and if there is a graph like this, then this represents positive acceleration and this represents negative acceleration. And here, after applying brakes, the vehicle is approaching the observer. Okay, imagine you are standing in a bus stop and a bus is approaching you. After applying brakes, the vehicle stops. So that is this graph. In this case, you are in a bus stop. Some other bus leaves the stop. While going away, you are in a bus stop. A vehicle or a bus is approaching you, but if this is the shelter and you are standing here, bus approaches from this direction and stops somewhere here means from you the vehicle is going away and after that it stops. So that is this curve. This, you are in a bus stop, you are standing, this is the bus. After approaching from this side, the bus stops here. See, after crossing you, it stops here. That is this. But in this case, before approaching you, it stops. So these two are represented by these two curves. Students, you have to copy all the graphs with all the statements. Velocity time graph. Graph is, or the curve is parallel to time axis, means velocity is constant and it is above time axis, so it represents positive velocity. Suppose if there is a graph like this below x-axis, then this represents negative velocity. Negative velocity, positive velocity. Let me write minus v. Minus v stands for negative velocity. Plus v stands for positive velocity. So we have to write this statement. Velocity time curve represents a body moving with uniform velocity. In both the cases uniform, it is positive, it is negative. Positive means in one direction, negative means in the other direction. In this graph, velocity is increasing. Observe, height is increasing with respect to time. Then this should be acceleration. This is also acceleration. This represents acceleration. This is also acceleration. But this acceleration starts with zero velocity. So from the beginning, initially the object is at rest. From there the vehicle is accelerated. Here vehicle already has some initial velocity. You can denote this by u. From initial velocity u, the vehicle is accelerated. But both of them represents acceleration. So in velocity time graph, if there is a straight line, then that represents acceleration. Here velocity decreases with respect to time. Straight line, but it is decreasing. Still it represents acceleration. If this is positive acceleration, then this is negative acceleration. Non-uniform motion, because velocity is changing with respect to time haphazardly. Therefore, it is better to use non-uniform. That's enough. This curve is not possible. This is also not possible. Guess? At some time, body cannot have different velocities. See, this vertical line cuts the curve at different places. So at some instant of time, the body cannot have different velocities. Second explanation, with respect to time, if the curve is going back, time, we cannot travel back in time. For that reason, these two curves are not possible in velocity time. This is possible. Why this is possible? Because the curve is not going back in time. It is changing up and down. Therefore, this represents non-uniform. Students, you have to copy the statement for this. Here you should say it is not possible. Even this is not possible because at some instant of time, body is having different velocities and it is approaching infinity. Acceleration time, uniform, because acceleration is not changing with respect to time. Acceleration is increasing with respect to time. Acceleration is decreasing with respect to time. Increase in acceleration is constant. Decrease in acceleration is also constant. Here, decrease in acceleration. Here, not possible. Vertical line means at some instant of time, it is having different accelerations and approaching infinity. Not possible. It is going back in time. Not possible. The motion is back in time. Not possible. Cartesian coordinate system. Observe these two curves. First curve, second curve. First curve, the y value increasing with respect to x value. In the second case, y value decreases. See, height is decreasing with respect to x value. Here height is increasing. So we say that this has positive slope because height increases, y component increases, and this has negative slope. Let this be first note. Second note, y, x, this is the given curve. Let me draw a line parallel to x-axis and a line parallel to y-axis. So I am trying to construct a right angle triangle. This is delta y, change in y value. This is delta x, change in x value. Let this angle be theta. Slope of a curve denoted by m is equal to tangent of the angle subtended by the straight line with respect to positive x-axis. Now you extend this curve. See, this given curve cuts the x-axis at this point. If this is theta, this is also theta. Students, guess the nature of angles. These two are equal. Why they are equal? What sort of angles? Corresponding angles, right? If this is theta, this is also theta. Tangent of this theta, tangent of the angle subtended by the curve with respect to positive x-axis, because we can get another angle here. Don't consider this with respect to positive x-axis. Tan theta is a measure of slope. So m equal to tan theta is opposite by adjacent, delta y by delta x. You will learn more about this slope in coordinate geometry, mathematics. For time being, this is enough. So in physics, if this is a graph of position, time, slope of position time means you have to consider unit along y-axis. See, delta y, unit along y-axis should be meter. This is slope, this is meter. Time, delta x is along x-axis, so along x-axis there is time. Second, meter per second, we are getting meter per second means slope of position time graph gives velocity. Next, one more example. This is velocity, time. Slope of velocity time means we have to consider delta y. So slope equal to unit of velocity is y component is meter per second. X component is time, it is second. So what we get is meter per second square. So slope of velocity time curve gives meter per second square. Just divide this unit by this unit, unit of y by unit of x. Okay. Slope of velocity time curve gives acceleration. Similarly, students, guess runs over. Slope of runs versus over means y axis runs. So slope of runs versus over in a cricket match gives runs by over. Runs per over, nothing but run rate. So you can use the concept of slope for any graph. Okay. Third note, area under the curve. One more important topic with respect to graphs. This is y-axis, x-axis, this is the given curve, y, x. I want to get area under this graph. Area under this graph means this rectangle. Area under the curve represents this rectangle. What is area of a rectangle? Area of a rectangle is length into breadth. Length into breadth. So this is x and this is y. So x into y. To find area under a curve, you should just go to the product of y component and x component. Example, in the case of velocity time graph, area under velocity time graph represents, I said, take the product of this unit and this unit. Time is second, y component is velocity, unit of velocity is meter per second. Product of these two means per second, second. What we get is only meter. Meter is for displacement, right? Therefore, area under velocity time graph represents displacement. Similarly, area under acceleration time. Acceleration time. Go to the product of these two units. Acceleration is meter per second square. Time is second. Meter per second square into second is meter per second. So area under acceleration time graph gives velocity. So to find area, go to the product. Previous case, to find the slope, y component by x component. Okay. Students, note down all the graphs, all note points. From next topic onwards, we will be using graphs.